Welcome to primary science. Use your common sense to interpret the problems and think carefully. Use a logical mind to present the answer. Today, let us look into monads and their characteristics. The content will talk about the types of monad, characteristics of monad, how to monetize and how did these monetize, then follow with Q&A. Basically, we have three types of monads to be learned today. One is permanent monads, two is electromonads, and another one is temporary monads. Permanent monads are rare earth monads, can be found in the nature. You can find it from the refrigerator door, which consists of flexible monads stuck to the front of the fridge. The material we call neodymium iron boron and submarine cobalt. Electromonad actually is a man-made monad using electricity, or we call batteries, with wires wrapped around the metal core. This core usually is the iron. For the attached example, we're using the batteries to supply the electric current. Once the electric current passes through the wire, a magnetic field is generated. Until the current is cut off, magnetic field will be gone. Temporary monad is just like a short-lived monad. It carries the magnetism within a short period. For examples, the magnetic materials like paper clips, metal nails, or other items made of soft iron can be magnetic when exposed to the magnetic fields will temporarily behave as monads. Magnetic and non-magnetic materials. To make a monad, we depend on the magnetic materials such as steel, iron, nickel, and cobalt. Remember, not all metals are magnetic materials. What are the non-magnetic materials? Just like we have mentioned, not all metals are magnetic materials. So now, look at these metals. Examples: gold, copper, or we call bronze, silver, and aluminium. It's very easy to remember when under competitions, when you won three prizes, they are gold, bronze, and silver. Is it easy to memorize? Okay, all insulators like glass, ceramic, wood, rubber, or paper are called non-magnetic materials. Characteristics of monad. Can you look at this video? When the monad is thrown in, all the nails, coins made of iron will stuck with it. Or we can say that monad can attract magnetic materials. For natural monad, like permanent monad, they have north pole and south pole. So this is a very important statement you must memorize. Unlike poles attract, like pole rebel. That means when there is a north pole and south pole put closer to each other, there is an attraction force. Like poles, for example, north pole and north pole put near together, they will have a force of repulsion. If you place a permanent monad, or we call monad, in the air, we can see that this monad is always pointing to the north-south direction. So, what is magnetic force? Magnetic force is the monad can attract or repel magnetic materials or objects. Remember, magnetic force is always strongest at its poles. At the center between the north pole and south pole are weakest. Another point is magnetic force can pass through non-magnetic materials, for example, glass, papers, etc. Let us look at the first video, see whether can you recall the last few statements mentioned in the last slide. Remember, I say the most important statement is stronger magnetism at weaker magnetism is located at. Okay, now we look at the second video on the right. So, monad is always pointing to which direction? Look at another video. what it says about the magnetic force. If you can't remember, please refer back to the last slide. Magnetizing temporary magnet. As we know, not all the magnets come from the nature. So we want to know how the temporary magnet can gain magnetism, or we call magnetic force, through three methods. 1. Stroking. 2. Electricity. 3. Induction method. Look at stroking methods. First, we must choose the magnetizing object, example iron bar. Initially, the iron bar consists of south magnetic elements and north magnetic elements. So these two elements at the beginning, they all mingle together. They are all disorganized. So now we're using the natural magnet. For example, we're using the south pole to stroke from left to right, continue left to right, and left to right. So the south pole will attract the north element to the right. After few strokes, you will see most of the north element will be able to go to the right. So left the south element to the left. Therefore, it becomes a temporary magnet. The method we are using electricity. In this example, we're using battery as the electric source, and the iron bar is sitting inside the coil. Second method is using electricity. This method we call electromagnetic method. In this example, we're using the batteries to supply electric current running through the coils. The iron rod becomes temporary magnet, or we call electromagnet. Third method is called induction method. We're using the natural magnet to go near to the iron rod or magnetic objects. So this magnet will induce the iron metals and to bring the north elements and south elements in order to become temporary magnet. In this example, the south pole is approaching the iron rod, so the end of the iron rod will become north pole and the other end will become south pole. Since we know how to magnetizing the temporary magnet, we also need to know how to demagnetizing temporary magnet. Temporary magnets can be demagnetized, or we call loss of magnetism, by number 1, dropping, 2, hitting, 3, hit with a hammer. Dropping method is pretty simple. We just use the temporary magnet, just randomly throw onto the floor. The magnetism will be lost because the north and south elements will be disorganized. Using heating method, also try to use the heat to make the north and south elements not in order so that it will lose its magnetism. Third method is using the hammer, randomly hit onto the temporary magnet so that it will lose its magnetism. The summary notes here is to help you to memorize the important points and prepare yourself for the examinations. Are you ready to do some questions? We try question 1. 4 metal rings A, B, and C placed into a smooth plastic rod in the tree arrangement as shown. Based on your observation, which of the metal rings are definitely magnets? Explain your conclusion. Look at arrangement X. Some of them are attract, some of them are repelled. So, shall we try some repulsions? In arrangement X, A and B are repelled. How about arrangement Y? B and C are repelled. Arrangement Z, A and C are repelled. Therefore, we conclude A, B, and C are magnet, or we call permanent magnet. Only permanent magnet can be repelled. This is the conclusion. Question 2. What are the likely reasons the needle cannot pick up any paper iron clips? List 2 possible reasons. Most of the paper clips are made of iron, so normally the question will not include paper iron clips. It only indicate it's paper clips. Look at the picture. It's using stroking methods. First, you can ask, is the method correctly used? Number 2, you can ask whether the needle is it the right type of materials have been used. Well, let us check whether your answer tallies with the recommended solutions. 2 possible reasons. Number 1, magnetizing using stroking methods must be one direction, from left to right or right to left. If the magnet is rendering stroking, needle cannot be magnetized. Number 2, needle is made of non-magnetizing materials, or you can say needle is made of copper. Are your answers similar to this? Shall we do a short revision? Can you look at the diagram? There are 2 objects. One is magnet, one is a rock. They are hanging freely in the air. The question is a rock a magnet? Why? Can you get an answer? The rock is not a magnet because the rock can attract to the magnet. If it is a magnet, it must be able to repel. Okay, look at next pictures. There is an iron clip sitting on the floor, and there is thin sheets of materials. Also, there is a magnet resting on the floor. The question is, can a strong magnet bring iron clips to the right if the thin sheet is made of paper? Paper is a non-magnetic material, and magnet produce the magnetic fields can be able to pass through the non-magnetic materials. Therefore, it will be able to bring the clips to the right. So take note that as long the sheet is made of glass, copper, iron, non-magnetic material, it will be able to attract the clip to the right. Okay, just enjoy the video for this application on magnets. At the end of this video, we hope that you can memorize the summary notes before going for the examination. Make sure you read the questions carefully. Believe yourself, you can do well. Thank you.